Hello guys, my name is Om Khanapure. I am going to talk about our topic, that is the CO2 leakage detector in identified areas where the paper are kept. It is observed that the various pulp and the paper industry, the CO2 is formed by various chemical reaction, purification process and the pulp formation. The CO2 formed inside the lab is due to because of some burning process like uh, friction between the machines. So the CO2 is very harmful for the human health. So that's why the sensing the CO2 and reducing its effect in plant or the industry is very important. Thank you.
Hello everyone, my name is Vedant Lande and my MIS number is 11210940. Our group has chosen an MOS sensor, also known as metal oxide semiconductor sensor, to detect the CO2 leakage in the plant. I'll be explaining to you how an MOS sensor works. An MOS sensor works on the principle of change in resistivity of metal compound, which helps in detecting the amount of gas. An MOS sensor has a thin film or metal strip which is exposed to the air that we test. As the targeted gas is passed through the sensor, the metal film or strip undergoes corrosion, which reduces the resistivity of metal compound. As the resistivity of metal compound decreases, the current flowing through the sensor would also reduce, and this helps in detecting the gas. Now my friend Jashak would explain the block diagram of this sensor. Thank you.
So hi, I am Jashak Desai. My MIS is 6122090011. I will be explaining the block diagram of our chosen sensor, that is a CO2 sensor. We have chosen an MOS type CO2 sensor. So the basic block diagram consists of an input. The input is CO2 gas. So when the CO2 gas will fall on the sensor, which is the MOS sensor, it is a metal sensor. So when it will fall on the sensor, a corrosive reaction will take place on the surface of the sensor. That corrosive reaction will change the resistivity of that sensor, which in turn would change the resistance. Now, a change in resistance would cause a change in current as well as the voltage, because they are interrelated. So as the current or voltage will be changed, that voltage will be sent to a comparator device. The comparator will have an already reference voltage. That voltage reference will be equal or less than the voltage that will be there shown by the sensor when the ppm level is higher than normal human conditions. Now that when the comparator reference voltage is lesser than the voltage input from the sensor, that will trigger the comparator to give out a digital 1 signal as a signal of on. As the signal of on is sent, that signal will be sent to a triggering circuit, which will be sent to an alarm or a task which will help to remove the CO2 from the room. By that I mean that the signal will trigger a system which would automatically start the exhaust fans and remove the CO2 from the room.
So now here we are going to discuss about the characteristics of the metal oxide semiconductor sensor. In this topic we are going to specially discuss about what is the range of this sensor, what is the accuracy of this sensor, and what will be the power consumed by this sensor. So first of all, the accuracy of this sensor is 3%, and the power consumption of this sensor is about to 660 milliwatt, and this sensor works between the range of the 2000 ppm to 5000 ppm, and the sensor will most perfectly work on the pressure of about to the 2000 ppm.
So in making this sensor, there are various human problems that we have to deal with it. Like this sensor, the humans can detect up to 3000 ppm of pressure. We cannot survive more than that. So this sensor can tell us if the pressure is above 2750 ppm. So it will warn us, and as we know, the voltage regulated is much greater than a voltage reference. So the comparator will set itself as the alarm will trigger and it will warn us.
So now I'll be talking about the governing equation of this sensor. Now the governing equation of this sensor basically works on the formula that resistance is equal to the resistivity of the material into the length of the material divided by the area. Now resistivity depends on the material properties of that metal. Now as the metal will get corroded or will react with CO2, the mechanical properties and the material properties of that sensor would change. Now that change will cause a change in resistivity. As resistivity will change, as it is directly proportional to the resistance would change. By using Ohm's law, that is V is equal to IR, that means that V is directly proportional. So the voltage that will be generated will be directly proportional to the resistance. As resistance would change, the voltage would change, and as voltage would change, we'll get the output that the CO2 level is more or less, or depending on the voltage level, we can do the further output.
Placement of sensor. First, sensor would be placed near the part where stocking of the paper taken place. Second, stocking is the roller of the paper under 2 roller pressure. Third, to collect the paper coming out the roller after being stocked, people will be present here. Fourth is to reduce the risk of CO2 poisoning in those people. We need to keep the sensor in that region. Those it will be sense the CO2 level in that area of measurement CO2 level.
So hey guys, my name is Vishal Motan and I am going to talk about the risk of this sensor. The risk in this sensor are very less, but the temperature variation also changes resistivity. To reduce this, we can also use the thermocouple sensor to regulate the temperature and composes for that temperature. Thank you.